Okay, we'll begin, and let's see. I think, do I have a syllabus posted? I think I do. Maybe not. Maybe I need to update it. Okay. Well, anyway, we have multi-factor authentication, and I am a big fan. I gave my spiel earlier today. If you were in 102C, you heard it, and if you didn't, that's okay. You don't have to hear it again. Okay, well, today is our class. Oh, I have not added a syllabus. All right, I got to add one. Stats 131, Python and other technologies for data analysis. I'm really excited for the class. I also have no idea what I'm doing, okay? This is the very first time, and the objectives for the class are not defined. We haven't, I want you guys to learn Python, but it's not a computational statistics class. We're not going to try to or do Monte Carlo or things like that. But I want to give you guys some familiarity with Python and some other stuff that I think is useful, especially if you're thinking of going into industry, okay? If you're going into grad school, sure, this stuff can still be useful, but the truth is everything, in 5 years, whatever content I've covered today will be completely outdated, okay? And so if you go into industry, this stuff is only current for a couple years. I'm assuming Python will be around for a while, but I purposely left it vague and other technologies just so that in the future we can constantly modify and update things accordingly. So we don't run into the problem of Stats 130 where it says SAS and Stata and I don't know whatever else it has, but things have kind of moved on from it, and those tools still exist, but are used in a much lesser degree, I think, today. So anyway, definitely we'll cover Python. And so I guess I have to finalize my syllabus. We'll pull up, I guess, my draft syllabus. Oh, this is always a little bit scary. I'm probably gonna have to make some changes. So, okay, office hours I've got set. It'll be the thing. Okay, all right, this is all outdated. I've made changes. Oh, I haven't ran this through yet. Okay, I apologize for not having a syllabus up yet. All right, I have to figure out the final grading scheme and how we're going to do homeworks and how we're going to do all sorts of stuff. The truth is, you probably don't need this class to learn Python. If you are ambitious and motivated and had time, you can go out on the internet. There's tons of resources to learn Python on your own. And many of you probably already have taught yourself various degrees of Python and things like that. And so I see myself as kind of a curator of content. I'll try to go through the internet and find useful things so that you can kind of invest your time wisely in terms of what you should learn. I think there's a for-profit company called DataCamp that offers tutorials and things. I think they're very good, and I managed to kind of get this educational, accounts for you guys, all right? And so you should have received a DataCamp invitation over spring break. Some of you guys have signed up through that. Not everybody, but I think I'm going to assign probably DataCamp things as homework, and that will be kind of our base homework. Again, this is my first time doing it, so I'm not sure how much to assign, how much is going to be too much, and how much more you guys want. For a lot of my other classes, I enjoyed writing the homework assignments and throwing in a bunch of I don't know, theory and activities for you guys. This one, it's a little bit different. We're gonna have to just kind of play it by ear, and you guys are my very first class, so we're gonna learn along the way, and please don't hold it against me if things don't turn out the way that I might have hoped for. But so I'm gonna try to assign things through Data Camp, and so if you haven't, you'll need to sign up for a Data Camp thing. You should be able to sign in, and there's different courses, I think. So I'm like working through their courses as well, trying to see what's covered in each of these things. And okay, I've created assignments, I think, and DataCamp says they integrate between like CCLE and like if you complete it here, like your scores will transfer. I don't know if that's true. I think you have to click the link here on CCLE and then you do the assignment, and I think it will be sent back, but I'm not 100% sure. So we're gonna try to figure this out. It shows up in the grade book and whatnot. Okay. So we'll spend several weeks covering Python, Git, and other stuff. I think the primary grading components, we're gonna have a midterm probably during 7th week. Okay, I'll set a midterm exam during 7th week. All of this will be finalized in my final syllabus that I'll get posted. I'll have a midterm exam, and then we're gonna have a final project. And that will be like a group project thing. Most likely I will have you find some kind of data set online, probably from Kaggle. And then and in your groups, you'll do some kind of data analysis using Python. And you'll create a presentation and a video, and that will be that. Okay, so it'll be a final project, not a final exam. And I'll probably during the 2nd week I'll start laying out more details about the final project, and you guys can start thinking about groups and whatnot. Before I get into Git and other stuff, are there any questions in general? Yes.
So when I signed into Data Camp, some of the activities that, at least under the assignments tab, I completed like years ago. So should I create a new account?
You should have gotten an email, and that's the email that has the free account. Okay.
Right.
That might mean you have to redo some activities. If that's the same account, that like if you get the email and it's already the one that you already have completed, I think you should get credit for these past things, but I'm not 100% sure. You might have to click the link here. This might be a huge mess. I don't know. I might have to just say like, all right, export Data Camp and then try to manually import these myself. I'm not sure. They said it should work, but not everything always that should does. So, but ideally you click this, you do the thing through here, and then it will send the score back to CCLE. Okay? If it doesn't, we'll iron out the wrinkles as it goes through. Okay, but I don't know. Yeah, we'll see. Did anyone not get their thing? Okay, send me an email, and then I'll try to resend the link to the Data Camp thing. Okay. All right. All right. Well, we're gonna start off with Git before we get into Python. Okay, so I don't know how long we'll spend on Git. Maybe a couple days, maybe the first week, I don't know. Oh, all right, sorry. All of this will come out in the syllabus, and once I have the finalized syllabus, I'll go over it. But okay, so we'll have a midterm exam, we'll have final project. I'm also going to have probably like a quizzes like once a week, maybe a little bit more, maybe a little bit less or something. Just to kind of make sure you're keeping up to date with content and stuff. And these will probably be multiple choice type deals, okay? I'll figure this out. Maybe the quizzes are total, maybe they suck, I don't know, and we won't do it. But we'll figure things out. Things will have to be a little bit flexible for this very first trial run here, okay? Okay, so let's talk Git and GitHub. All right, you've probably heard of GitHub, and maybe you're aware of the separate and related technology Git. Okay, so GitHub, a lot of people host their, whatever coding projects they've been working on are often hosted at GitHub, and it serves as almost like a little portfolio of stuff that you've worked on. And that's a great use of GitHub, but the original kind of primary purpose of GitHub is to have this collaborative framework so that multiple people can work on coding projects together and have a way to get different people to work together on a coding document, okay? So now that we're at this, now that we have the internet, we can, you can open like Google Docs and write an essay collaboratively, right? And you write things and somebody else write things, and it updates everybody's view of the document. And GitHub is kind of like that, but it's different because when you write code, it's not like English words where you can just add stuff and it's fine. It's like when you write chunks of code, it can definitely alter other things. And so you have to be, there's a lot more kind of rigor in what we should allow, what changes we should allow, and things like that. Okay, and so GitHub is built on this technology called Git, which is at its most basic level, is a version control system. Okay, and in this, where did my cursor go? Hang on. Okay, let me draw a little picture here of how this works. Okay, and I'm starting here before we even get into Python because this is just like, how are you supposed to save your work? Okay, this is what it boils down to. How do we save our work, and how do we make changes to our work? And we have to start there because I want you to get into some like good habits regarding this, right? And a lot of companies use Git and GitHub, and so if you're familiar with it, then that's a good thing. Okay, let's get this going. 131. And everyone here is graduating, right? That was like the condition to get in the class. So like 10th week we'll have like I don't know what we'll have. Congratulations party. Okay. All right. Okay. So this is probably your file workflow without Git. Okay. And it looks like this, right? You write a file, okay, and then you make changes. Then you save it, okay, and then you make more changes, and then you save it, okay, and that's fine, okay. This has worked for many years. We've been fine, okay. Sometimes, however, you make a change and then you realize, uh-oh, this doesn't work. And you need to go back to an older version, right? So this is fine if every update So this works fine if every update is good. Okay. But sometimes we break things, right? And this is probably something we have done and are upset at ourselves about, right? Okay, sometimes we break things. And if you saved your file, there's no way to go back. You can undo, but like if you've saved it and you've closed it and you rebooted your computer, there's like no way to get back that old version that you used to have, okay? So what can we do, right? Sometimes we break things and you say, I want my old version. It was working, right? Okay, and it's gone. You can't do that. So after this experience, you say, okay, I don't want that to happen again, so I'm going to make copies of my things, all right? You start off with, you know, I don't know, you've got homework 1, and then .rmd, and then later on you make changes. But to avoid the problem, what do? You're going to do save as homework 1. Yeah, homework 1 version 2.rmd, right? And then make changes. And then you save as homework 1. And we've probably created like and this is like optimistic when you say like homework 1 version 1, homework 1 version 2, homework 1 version 3. But then sometimes it's like final paper, final version, and then you're like, oh no, final version with appendix, and then final version with appendix, and it just gets like this. It's just a mess, right? And then later on, you're like, oh no, I need to get the diagrams from final version, and I need to combine that with final. It's no good. So what Git does is you make changes, but it keeps track of every single change. Okay. So with Git, basically, all versions of the files in a repository is kind of the box that we have, okay? In a repository are saved and tracked. And so the way it works is on your computer you have your local disk, and you have some kind of folder, and then you have file1 Python code, and then file2.txt. And what you do is you say you're going to set this up as a repository. Okay, so this is now a repository, and you commit. You commit these changes. You say, I like these changes, I am committing them into Git, okay? And Git commit to Git, right? And then you make more changes. And then you commit, you make more changes, and basically when you make more changes, you save the local files. Okay, these saves to the local files are not yet committed, okay, and then you commit them. Every time you commit, you get something called a hash, okay? It produces a hash is a unique identifier for that state of the repository. Okay, you commit again, and this produces. Sorry, I gotta. Okay, and then produces another hash. And the process goes on, okay? And if at any point you say, I want to go back, you can do that. You can just tell Git, go back to the old version that I had from before, okay? And every time you commit a change, you need to enter a log entry. You need to enter like a line into your diary that says, this is the change that I made, okay? And then, and you tell Git, you know what? I don't like this. I want to go back to this state and time. And you can say, I want to check out this old version. You say, I want to check out this thing, and you give it the hash code, and it will pull out the old version that you had, okay? So every single change is tracked, and everything is logged, okay? In order to kind of save space so that it's not literally creating copies of every single file, Git just, what it does is it stores what's known as the delta. It just stores what changes have been made, and if you need to go back in time, it just kind of undoes those changes. So it keeps track of every change with every hash, and you know, if you need to go back, just check out. You check out the old version, okay? And you can commit that, and you can go back and forth and things like that. Okay, so that's the version control system, and that's perfectly fine. It's a good thing to have on your local thing. And then what makes this extra powerful is that, so Git is a great thing as a kind of a version control system on your own local PC. You can keep track of all of your changes. And so when you do the DataCamp Git tutorial, this works through the local version of Git for your own machine. And then so actually maybe we'll just start there, and then if we have time we'll talk about GitHub. Okay, so you're gonna go and download Git. Okay, is it safe to assume you guys, most of you are not currently using Git? I know some of you are, but all right, who's not using Git? Okay, yeah, so many of you are not, and that's fine. I probably don't, to be honest, I don't use Git for a ton of things. Just certain things, like you're like, okay, let's use Git so we can keep track of all of these old versions and stuff. But it's a good thing. All right, so you're gonna download Git. Here it says for Windows, but it's got it for Mac, and you download and you install. Probably the default settings are fine. And let's see. And you'll want to use Git Bash. Okay, Git Bash is the command line interface to interact with Git. There's like a Git GUI, which allows you to kind of click and point at things. It works and everything, but if you want to be taken seriously regarding your usage of Git, you're going to have to use the command line interface, right? It'd be like trying to say you know R, but only if it's click and point. I don't think that will suffice. It's already installed on my machine, so I don't know what's going to happen when I ask Git to install Git again. We'll see. Okay, so I would click next. Yeah, default things. So we want, yeah, the Git Bash. We probably can get rid of the Git GUI here, but I'll just leave that. On my Windows machine, I like to use Notepad++. That's just the text editor, but you have different options. You have like Vim and Nano and things, and I don't know what the options are on a Mac, but probably Vim and Nano will be offered and things like that. You can use Git from Git Bash, and if you have Git from the Windows command prompt, it also allows for Git Bash. These default settings are probably fine. Use the OpenSSL library, also fine. Check out Windows style. That's if you're on a Windows machine, this is what you'll have. If you're on a Mac machine, you're going to use the Unix style one, and it will probably be default to that. Mini TTY, also fine for terminal emulators. Okay, and then all of this. All right, so I'm not actually going to do that. And so we set that up. Here is my, so I'm going to just delete these files, and let me, okay, so when you have that installed, you can just start any kind of, go into any directory where you want your Git thing to run. And this is my terminal. Am I allowed to make it bigger? Let's see. Terminal window looks. Oh, text. Okay, let's make this bigger for you guys. Is that visible? Okay, so here I started this. It's already set up, but you're gonna you'll read through this thing, okay? The data camp Git. You can probably find other Git tutorials, but you're gonna start off with try Git. Oh, look at this. Okay, well, the data camp tutorial is pretty good. Okay, so you do a git init, and it's already initialized, and you can do git status. So whenever you want to create a new repository, the command is git init for initialize, and that will say this folder that I'm in is going to be designated as a repository. And what that effectively does is it creates this folder called .git, which makes it a hidden folder, but I mean you can see it, and that creates that folder. And right now I'm going to click Git Status, and I had just deleted some files prior to opening up Git. So it says these are the changes you have done, okay, and so it says these changes have not been staged for commit, okay? Which means if I type in git commit, which says commit these changes into the repository, these changes are not staged for committing, okay? So the way the process works is you have your state, you make changes to them, and you stage changes using git add, and then you have to type out exactly the file name that you want to make changes to, or if you want to just stage all changes, then you use git add and then the wild key dot, which is basically all the changes, okay? And then so you stage the changes and then you commit the changes. And this will use git commit. Okay, so I'm going to just do git add dot, and this will stage all of my changes. I can ask git for git status, okay, and it says these changes are committed, which means once I commit these changes, it's going to delete these files. Fine with me, okay? And I say git commit, all right? That's the command to commit the changes. Now, whenever you say git commit, you have to put in a log entry. You need to put in a message that says, these are the changes that were committed, okay? If you don't, Git's gonna pull up a text editor that just says, you forgot to put in the message here, okay? So if I just type in git commit and I hit enter, it pulls up a text editor here and it says, what are the changes? And I'm gonna say, okay, the changes were, I deleted 3 files. And I can say my branch, our project, whatever, and test file. Okay, so I'm gonna just say these are the changes. I'm gonna close that and exit out, and those changes have been committed, okay? And I can ask for the status, and it says you're on branch master, and there's nothing to commit. You are working on a clean tree. So this is my current repository, and it's up to date here. Let's say I want to make a new file, okay? What I do is I just say, here's a new file that I'm gonna do. I'll just call it test.txt, all right? And this will be like new stuff. All right, here we go. All right, so this is representing hours of work, and now I want to, so this file is available on my local machine, okay? And it's there, but if I ask for git status, that file shows up in red here, meaning this has not been committed to the repository. So if I check out an old version of Git, of my repository, this file is not tracked, it's not in there. So if I want to add that, I have to do git add, and I say add this file to it, okay? I do git add test.txt, and I ask for the status, and now we can see we're going to have this new file tracked in the repository. And then I commit it, all right? Now if I don't want to have to modify the file, I can just give it the option -m. -m is kind of just the shortcut, and you'll probably use this every single time when you do a git commit, so you don't have to write out in the separate text window, and you just say added test.txt. Okay, so this is your latest change here, and now it is in there. Okay, so I can do git status, everything is there. Okay, and we're right there. Okay, and so now I'm like, oh wait, I deleted that file and I want it back, right? So I can go to git log. This keeps track of everything I've done. And there's stuff where I was messing with a different branch, okay? So we can see the most recent commit has this crazy hash, and I added test.txt, all right? And then the one before that is where I deleted the 3 files, okay? And then the one before that, I had stuff. It's the result of the merge pull request. Okay, so and you can there's even more in this thing. You just kind of click quit here, Q to exit out the log. You have to hit Q to exit the log. And so what I want is I want the repository before I implemented this change where I deleted the 3 files. Okay, so that hash is 35F4D850. Okay, you don't have to type out the whole thing, but you can just say git checkout, and you just type in, you know, kind of the first few letters, and that's probably enough for it to recognize, okay, this is the one you're talking about. Okay, and so I type that in, and so it says now you're in a detached head state, and if I go back here into my folder, those 3 files that I deleted are still there. Okay, And my new file that I had created, which was called test.txt, is gone. It has basically just rolled back those changes, okay? And I can see, oh, you know what? This was that file. That was the important piece of information I needed. And I want to go back to the most recent one, okay, which is where I added test.txt, okay, so I can check out just the current one that I have, A0BB3, okay, and I can go back, you can just do checkout, and actually the most recent commit is just known as head, okay, and you can go back like, oh yeah, git checkout, and the most recent commit is known as head, and you can just say that, and it will, oh wait, did I not do this right? Git checkout, maybe I have to type in the, maybe I have to go back to this one. Okay, A0BB3, okay. A0BB3. Okay, and it has rolled back kind of my folder to whatever it was, okay? And I can ask for git status, I think. Oh, it says head detached. So, yeah, head detached at A0BB301, and that's fine. And we can just kind of do git add, and we'll do git commit. We'll just do reattach. There's nothing. Well, here, let's just try making a change here. Now I'm a little bit nervous. Okay, so new stuff. All right, just we'll do added line 2. Okay, we'll close that out. Okay, git status. Okay, so we're gonna do git add everything. Git commit with a message added line 2. All right. Okay, and I think everything is good now. No, head is still detached. How do I reattach my head? I forget. Okay, so this is just the local Git working right here. I want to introduce the concept of branching, okay? And I know we only have a few minutes left. The idea here is your main repository is known as the master. Okay. So yeah, you stage your changes, and you commit your changes with git commit. Okay. We'll save that. Your main repository is known as your master. Okay. And this will become a very important concept, especially in GitHub, is that any changes that you make to master should be good changes that you can submit and make public, and they are fully operational, okay? And maybe nothing is at this point is operational, but basically things on master, if this line represents master, everything needs to be working. Okay. If you want to try something and like make a modification to your program that's currently working, like if you're trying to optimize something, okay, and your optimization might break things, don't make your changes on master. What you need to do is you need to branch, okay? You create a branch, you make your changes, make changes, add changes, and commit changes. Okay, and you repeat this until it works, working again. And then once it's working again, then you merge your changes back into master. You don't want your master repository to ever be in a state that it's not working. So you get something working, great. You can put that in master. You want to optimize things and change things up. That's fine, but don't mess with the master. Branch it off, make your changes. If things break, it's fine. You commit your changes. Once it's working again, then you merge back into master. So this step right here is called a branch, and this part right here is called a merge. Okay? If this is how it goes, we're fine. Okay? Sometimes you can run into things called merge conflicts, and those are like headaches, and we want to avoid it. And the Git tutorial we'll do a small example of a merge conflict. But generally, what a merge conflict looks like will be something like, here's master, here's your branch, and you want to merge it back in here. But while you were working on this branch, someone else brings another branch and merged in before you did, okay? And then if this happens, then you maybe encounter a merge conflict. And merge conflicts can be a headache to work through. I guess on Wednesday we'll talk about GitHub, and I'll talk about some strategies you can employ to help you avoid merge conflicts. But sometimes they happen, okay? So, all right. What I want you guys to do, at least tonight, if you haven't done so, is get your DataCamp account working and just try working through the DataCamp Git tutorial, okay? And that will work on Git on the local machine, okay? And then on Wednesday, we'll talk about GitHub and getting your local repository to synchronize with a remote repository, and that will be an important concept. Okay, so we'll start there, and we'll see you guys on Wednesday.